In this video, we will learn how to find the area bounded by two curves. Suppose there are two continuous functions f and g, and we want to find the area of the shaded part which is bounded by the function f and g. Now, from the previous video, we learned that if we integrate f from a to b, then we will get the area above the x-axis, below the function f, and between the limit a to b. Similarly, if we integrate g from a to b, then we will get the area above the x-axis, below the function g, and between the limit a to b. Now, if we subtract the second one from the first one, then we will get area of this shaded part. Area of this shaded part. That means area of the shaded part is integration of from a to b f of x minus g of x. F of x minus g of x. Therefore, the theorem to find the area between two curves is if f and g are continuous functions on a to b and g of x is less than or equal to f of x for all x in ab, then area bounded by the function f and g are given by this formula. The condition g of x is less than or equal to f of x is very important. That is, to integrate over a domain a to b, one function has to be bigger than another one. At the end of this video, we will discuss two examples to clarify it. In this example, we have two functions y equals to 2 and y equals to 4, and lower limit x equals to 1 and upper limit x equals to 5. If you draw the graph, then y equals to 2 is this one, y equals to 4 is that one, x equals to 1 is this line, and x equals to 5 is that line. So we need to find area of this bounded part. Since y equals to 4 is bigger than y equals to 2, so f of x would be 4 and g of x would be 2. Lower limit a is 1 and upper limit b is 5. Now, if we apply the formula and evaluate, then you will get the area as 8. Now, if you want to solve the same problem without calculus, then this is a rectangle of length 4 and width 2. So its area would be length times width, so 4 times 2, which is 8. That means we have total 8 square unit on that shaded part. For this example, we have two functions y equals to e to the power x and y equals to x, and it is bounded by the sides x equal to 0 and x equals to 1. Now, if we draw the graph y equal to e to the power x, it becomes this type, and if we draw y equal to x, this becomes this straight line. Now, on the interval 0 to 1, e to the power x is bigger than x, so f of x would be e to the power x and g of x would be x. Lower limit a is 0 and upper limit b is 1. Now, if we apply the formula and evaluate, then you will get the answer as e minus 3 over 2, where the approximate value of e is 2.718. For this example, we have two functions y equal to x square and y equals to twice x minus x square. But here we don't have any lower or upper limit. Now, if you draw the graph y equal to x square, then it looks like this red curve, and if you draw y equal to twice x minus x square, then it becomes like this. Now, at intersecting point, we need to equate both equation, and if we equate, then you will get x equal to 0 and 1. So x equal to 0 is this point and x equals to 1 is that point. So lower limit a is 0 and upper limit b is 1. Also, the function twice x minus x square is bigger than x square on the whole interval 0 to 1. So f of x would be twice x minus x square and g of x would be x square. Now, if you apply the formula and evaluate, then you will get the area as 1 over 3. For this example, we have two functions, y equal to sin x, y equal to cosine x, lower limit x equals to 0 and upper limit x equals to pi over 2. Now, if we draw the graph y equal to sin x, then it becomes this red curve. And if we draw y equal to cosine x, it becomes this one. They intersect at this point. Now, to find this point, equate both of them and solve for x, then you will get x equals to pi over 4. So this one x equals to pi over 4. Now from 0 to pi over 4, the function cosine x is bigger than sin x. So f of x would be cosine x and g of x would be sin x. Lower limit a is 0 and upper limit b is pi over 4. So if we apply the formula and evaluate, you will get the area as square root of 2 minus 1. So this one is area of this part, only this part. Now from pi over 4 to pi over 2, from pi over 4 to pi over 2, the function sin x is bigger than cosine x. So f of x would be sin x, f of x is sin x and g of x is cosine x. Lower limit a is pi over 4 and upper limit b is pi over 2. So if you proceed same way, then you will get area as square root of 2 minus 1. So this one is area of this part. So total area would be area of this part plus that part. So square root of 2 minus 1 plus square root of 2 minus 1, which is this one. This is the last example of this video. Here we have two functions y equal to x minus 1 and y square equals to twice x plus 6. So if we draw it, then it becomes this red straight line. And if we draw it, it becomes this parabola. At intersecting point, we got x equals to negative 1 and 5. So this is x equals to negative 1 and this is x equals to 5. If we integrate from x equals to negative 1 to x equals to 5, then we will get area only this blue part. But area of this yellow part remain missing. To solve the issue, let's consider the domain along y-axis. Now, if we rotate this curve 90 degree counterclockwise, then it becomes like this. So, did you notice on the whole interval y equals to negative 2 to y equals to 4, the red curve is bigger than the other one? So, we can apply the formula. Since we are considering the domain along y-axis, so write the function f of y equals to y plus 1 and g of y equals to 1/2 times y square minus 6. Lower limit c is negative 2 and upper limit t is 4. Now if we apply the formula and evaluate, then you will get the area as 18. Thanks for watching.